So what is the solution of a differential equation? So let's see how to find the solution and what is the solution first of all. In general, a solution of nth order differential equation involves n arbitrary constant. What do you mean by order? So if you have differentiated only one time, that is first order. Order is 1. If the order is 1, when you integrate that order, first order derivative, you get a constant, arbitrary constant. Okay, that is why that will have only one constant. Whereas if you have two second order derivative, when you integrate this one time, you won't get the solution. So if you get integrate one time, you get one constant. Further, if you integrate, you then only will get the solution. Then you will have one more constant. So that is what the statement says here. In general, a general solution of nth order differential equation involves n necessary arbitrary constant. So as these are the constants are not definite, which are arbitrary, that is becoming general solution. Okay. So our part is to understand both general as well as a particular solutions of a differential equation. So if we don't know what is a constant, then it becomes general. Okay. But specifically, if you have enough data to understand these constants, that becomes a particular solution. That means we have got exactly the meaning value of the constant also. So it becomes a particular solution. So when using the variable separable method to solve a first order differential equation, we must necessarily include an arbitrary constant as soon as the integration is completed. As a result, it is evident that upon simplification, a first order differential equation solution involves just one arbitrary constant. I'll come to this later. What is it? By assigning a certain values to the random constant, a differential equation can be solved using a particular solution, which is derived from the general solution. So when we have some variables to substitute in the differential equation, general solution, we will be able to find out the value of the constant. Then it becomes a particular solution. Okay. Depending upon the question, we may be given with the requirements for finding a values of a random constants as either boundary conditions or initial conditions. Okay. So let's see what does it mean. Okay. By actually understanding by some questions. Okay. Yes. Let's see if there are any examples to make it clear about what is told here. See here. So how to find the solution? There are some examples here. Show that the function y is equal to e power minus 3x is the solution of the differential equation. So how do you know it is the solution of this is? If you want to verify it's the solution, we can do one thing. See, when they are not already given a solution, whether it is the solution of the given equation or not is very simple because we just have to differentiate it according to the order given. But if they are not given the solution to verify, we have to find the solution by ourselves. Then the process becomes complicated, which we're going to discuss in the next part right now. So we'll just have to show that it is a right solution or not. For that, what is going to be done is we're going to differentiate it according to the equation. Okay. So what is it? We have this y is equal to e power minus 3x. We want second order derivative. For that, what will you do? We'll first differentiate the given equation. Let it be I. Let it be 1. Okay. So differentiate with respect to x. What we get is e power minus 3x into minus 3. Am I right? Yes. So that is dy by dx is equal to minus 3 into e power minus 3x. Now, if I want to differentiate it further, again, one more time, so what will you do? We have to differentiate again means we are going to let it be equation 2. Now, d square y by dx square minus 3 into minus 3 e power 3x, right? So which will give you 9 into e power minus 3x, which is second order derivative of the given function. right? This is equation 3. Now we have to use this to get d square y by dx square. We need equation 3, and to get dy by dx, we want equation 2. Okay, minus 6y. So if we substitute all this, are we getting the right hand side equal to left hand side is the question. So that is 9 into e power minus 3x plus minus 3 into e power minus 3x minus 6 into what is y, e power minus 3x. So what are we getting? 9 minus 3 is plus 6 e power 3x minus 6 e power 3x, which is equal to 0, isn't it? That is equal to what? Right hand side. That means I can show that RHS, that is right hand side of the equation, is equal to left hand side of the equation. Hence we are proving that the given y power y is equal to e power minus 3x is the solution for the differential equation. Okay, yes. That is nothing but if y is being replaced by this, and if you multiply or add, we will definitely get the left hand side of the equation equal to right hand side. That means the proof is done, right? Is that clear to you? You want to check one more example like this? Yes. Check this. Please go through this quickly. I'll explain that after that. So we have to show that again. Y is equal to m cos x plus n sin x, where m and n are belonging to a real number, is the solution of a differential equation d square y by dx square plus y equal to 0. Please do that. To get that, we need to have a second order derivative of the given function, right? Yes. Shall we try it? So we want second order derivative of the given function. Y is equal to m cos x plus n sin x. So when I differentiate once with respect to x, let this be equation 1. Okay, what do we get? M minus m sin x plus n cos x. Am I right? Yes, let it be equation 2. Differentiate again with respect to x, we get second order derivative, which is minus m cos x, minus of minus become plus n sin x. That is equation 3. Now if I want d square y by dx square, I want equation 3, and if I want 1, I want equation 1 to get y. It is equal to 0 the same. What is equation 3? Minus m cos x plus n sin x. What is equation 1 saying? Plus m cos x. Okay, this is actually this is minus n, right? Yeah, this has to be minus n. This will be minus, then this will be plus n sin x. So what happens to this is everything cancels. We end up with 0, which is equal to what? Right hand side of the equation. So LHS is equal to RHS. That means it is proved that y is equal to m cos x plus n sin x is the equation, is the solution for the given equation. All right. Any question in this? These are actually particular solutions. Okay, this can be an example. Even the previous example which we had is a particular solution. So if you want to know what is particular solution, we know all the constants, everything properly. That's why it's a particular solution. Okay. So let us now understand, this is just proving the left hand side equal to right hand side, but they have given already the solution for us and we are just verifying. But there is an approach where without knowing the solution, we are going to find the solution.